Section 8.2 Trigonometric form of compressed number. The compressed plane and vector representation. So horizontal axis, we call this as the wheel axis. And then the vertical axis, we call this as imaginary axis. Each compressed number, a plus bi, when you guys see the a plus bi, this is represent the compressed number, determines a unit position vector with an initial point. So we're starting from O here, starting from the origin, we call this as the initial point. And then that's the point P, OP. The P will be the terminal point. We use the AB to represent it. In this example, 2 minus 3i, that will be the compressed number. Sum of two compressed number is represented by the vector, that is resultant of the vectors corresponding to two numbers. So look at this example. I do have a two compressed number, 4 plus I and 1 plus 3i. I want to add it up together to find out the resultant of the vectors, which is gonna be 4 plus 1, that'll be equal to 5. I plus 3i, that's gonna be equal to 4i. And then now we try to sketch on the coordinate system. So 1 plus 3i, this is talking about x equal to 1, y equal to 3. So I have this compressed number. And then I do have a 4 plus I. Okay, x equal to 4, y equal to 1. So we do have another one. Okay. When you add it up, you do have the resultant of the vectors, which is going to be 5 plus 4i. If you guys using the parallelogram rule, you could find that this one will be the resultant vectors. Example 1, expressing the sum of compressed number graphically. Find the sum of 6 minus 2i and negative 4 minus 3i. Graph both compressed numbers and their resultants. Okay, so first, try to add up these two compressed numbers. Add up the real part and then add up the imaginary part. You should get 2 minus 5i. And then, I need you guys graph both compressed number and their resultant. Okay, just like this picture. Okay, try to do it one by one. First one will be 6 and negative 2, right? Starting from the origin. Second one, negative 4, negative 3. And also starting with the origin. And this is going to be the resultant. So check your work. Okay, relationships among x, y, r, and theta. So let's say I have the OP, okay, this is my compressed number, x plus yi. And then x, this is represent the length of here, the horizontal axis. Y, talking about the vertical axis, the height of the P here. So that's what we got from the compressed number. Then we create the triangle. We do have the theta and then the hypotenuse that will be equal to r. So I would say cosine theta will be equal to adjacent over hypotenuse. So that's why I have x over r. And then I'm gonna multiply by r for both sides. So this guy I cancel out. I left with x equal to r cosine theta. And then I'm gonna do the same thing. I will have a sine theta equal to opposite over hypotenuse, y over r. And then I multiply by r for both sides. You should get y equal to r sine theta. I want you guys to box up these two formula. Okay, you guys need to remember these two formula. And then I will have another one, tangent theta. Tangent theta will be equal to opposite over adjacent, so y over x, given that x cannot be equal to 0. Okay, I do have one more formula here, tangent theta equal to y over x. Okay, how about R? How can you guys link up with the R, X, and Y? You can use the Pythagorean theorem, right? R will be equal to square root of x squared plus y squared. Okay, highlight this four formula. X equal to r cosine theta, y equal to r sine theta, tangent theta equal to y over x, and r equal to square root of x squared plus y squared. Polar form of a complex number. You can call this as a trigonometric form or polar form of a complex number. We just learned about the complex number in the rectangular form, which is gonna be z equal to x plus yi. When you see x and y, this is represent rectangular form. For the polar form, you're gonna see z equal to r parenthesis cosine theta plus I sine theta. Okay, this is exactly the same thing. It's just one in rectangular form, one in the polar form. Z equal to r cosine theta plus I sine theta. The expressions cosine theta plus I sine theta, sometimes you could write it like CIS theta. C represent cosine, and then you do have the I, and then S will be the sine, and then theta. Okay, CIS theta. So if you're using this notation, you could write it like R CIS theta instead of the whole thing here. Okay. The number R is the absolute value, or you could call the modulus of x plus yi, talking about the length of the complex number here. And then the theta will be the argument of x plus yi. Okay, remember this picture, right? R will be the modulus, and then the theta will be the argument of x plus yi here. Example 2, converting from trigonometric form to rectangular form. Okay, converted to polar form to rectangular form. Remember, rectangular form means I want the x and y here. Okay, x plus yi. So what we're gonna do? Pretty straightforward. I just let z will be the complex number equal to this guy. You just need to calculate what is a cosine 300 degree equal to, and sine 300 degree equal to. Okay, remember how to do it, right? Cosine 300, talking about the reference angle will be cosine 60. Right, what's cosine 60? That's a 1/2, right? How about sine 60? But it's a negative sine 60 because this is in quadrant 4, right? It should be equal to negative root 3 over 2. Okay, then we do have the negative here. Negative positive become negative. And then we're gonna distribute the 2 one by one. So you should get 1 minus I squared root 3. So this is the rectangular form, okay? X plus yi, rectangular form. And one more time, this is called trigonometric form, or you could call this is a polar form. Straightforward. You just need to calculate what is the cosine degree here, what is the sine degree here. Simplify it, you can convert it from the trigonometric form to rectangular form. Okay, how about converting from rectangular form to trigonometric form? So we want to do the reverse, okay? I give you guys the rectangular form x plus yi, and I want you guys convert it, go back to this guy. Step 1, sketch a graph of the complex number x plus yi in the complex plane. Okay, for this step, we want to know which quadrant of this complex number belong to, okay, because it affects the degree. Find R by using this equation, R equal to square root of x squared plus y squared. Step 3, find out the argument. Find theta by using this equation. Okay, but make sure you guys Do the step 1, sketch the graph of the complex number. Be sure to choose the correct quadrant of data by referring to the graph sketch in the step 1. So this is very important. It's gonna be affected by the argument. Okay, let's try it together. Converting from rectangular to the trigonometric form. Write negative square root 3 plus I in trigonometric form. And I want you guys to use the radian measure. So first, we want to sketch negative square root 3 plus I in the complex plane. Okay, this is x plus yi. So first, we're gonna know x that's equal to negative square root of 3. And then y that will be equal to 1. Okay, so step 1, try to sketch this complex number. Okay, y equal to 1, x equal to negative square root 3. So that will be in quadrant 2 here. Okay, so x equal to negative square root of 3, and then y equal to 1. Okay, so the data, the argument should be here. That will be the data. So first, we want to find out what is your R. Okay, so use the formula. Plug it in. You should get R equal to 2. Okay, so R equal to 2 here. Okay, now we want to find the argument, the data. So tangent data equal to y over x, which is 1 over negative square root of 3. Okay, and we try to rationalize, so that will be negative root 3 over 3. So first, let's find out the reference angle. Reference angle will be in radian. Reference angle will be pi over 6. And then, since this is in quadrant 2, so when we want to find out the argument, the data, that will be pi minus pi over 6, which is gonna be 5 pi over 6. So that will be the argument. So that will be 2 cosine theta plus I sine theta. Okay, we could use the notation 2 cis 5 pi over 6. This is how you guys convert from rectangular to the trigonometric form. Okay, first, try to sketch the picture. And then figure out the R and then the argument. Okay, 3b, write negative 3i in a trigonometric form. I want you guys try. What is x equal to? Okay, negative 3i means x equal to 0, y equal to negative 3. Okay, so x equals 0, y equal to negative 3, somewhere like here. Okay, that will be on the y-axis. So first, let's find out the R. You could use the formula, but actually straightforward. Here is a negative 3. So R should be equal to 3. Right? And then tangent theta, y over x. You could plug in the number, but you're gonna see x cannot be equal to 0, right? This means gonna be undefined. But think about it, on your picture here, what is your argument? Your argument will be starting from here to here. What degree is it? This is gonna be 270 degrees, right? So actually, you don't have to find out the tangent theta. Okay, by looking on the picture, you're gonna know theta will be 270 degrees. And then plug it in polar form. R will be 3 cosine 270 degree plus I sine 270 degree. Use the notation 3 CIS 270 degree. You could double check your work, okay? You could try to use your calculator to see what you get from cosine 270. What did you guys get from sine 270? And then times 3. It should be go back to the rectangular form. Okay, right? Last one. Write each complex number in its alternative form using calculator approximation as necessary. Okay, I want you guys try, do it by yourself. You need to use the calculator. Okay, use your calculator. Make sure you keep your eye, okay? Distribute the 6. That will be your final answer. Okay, B, 5 minus 4i. So try first step. Sketch the complex number in the complex plane. And then find out the R, find out the data. Okay, check your work. Your R should be square root of 41, right? And then this is x equal to 5, y equal to negative 4. So you know the data must be go to the quadrant 4. Tangent data, so negative 4 over 5. So reference angle will be 38.66 degree. And then since this is in the quadrant 4, right? So the data will be equal to 360 minus 38.66. You should get 321.34 degree. Okay, write it down in the polar coordinate. Or put it in the notation. Okay, look at the picture.